Hi everyone. I wanted to show you in this video how to look at the multicollinearity issue when you're running a multiple linear regression model. So if you recall from the presentation that I recorded for you, the first thing that you need to look at is to see if there are highly correlated predictors amongst your variables. So here I have a data set that I'm using for this example. It's a data set that has 41 observations, and what we did was to measure body fat percentage in women using two methods. We used the BOD-POD and we used a multi-frequency bioimpedance equipment. We also assessed dietary intake with a 24-hour recall in these people, and we wanted to know if there are differences in the measurements of body fat when these participants consumed 1 liter of water. So we wanted to know how hydration affects the body fat assessment. And for our purposes, what I'm going to do is try to create a model that predicts body fat percentage using dietary variables, and then we'll take a look at some of the issues with multicollinearity. So the first thing that I need to know is to see how the variables correlate with each other. So I'm going to run a correlate, an analyze correlate bivariate, and what I'll do here is add my variables to this box, and because most of my variables are continuous, I'm going to use Pearson's, which is already checked here. So I'm going to use age, how many calories they consumed in their diet, assessed by the 24-hour recall. I have total protein, I have total fat from the diet, carbohydrates, I have potassium, I have water from the diet, which includes also the water from the foods, and I have sodium, and of course my measure of body fat, which I'm going to use this one right here. Okay, so I'm going to click OK, and here's the correlation matrix. So you see how all variables are correlated with each other. And for this one, take a look at, if you remember from the presentation, we are concerned about values that are above 0.8. And if you look at the matrix here, you can see there are some there are. This one right here, the 0.81, which is the correlation between fat and calories. No surprise there. We do know that there's a high correlation between total fat and the total calories. Same with carbohydrates. There's a high correlation here, and sodium as well. You can see probably because some of the foods that contain the most sodium are also high in carbohydrate and or fat. So you can see that that's a problem. Then we have here sodium is also correlated with protein intake. And then I think there is nothing else. Everything else is we already talked about. Okay, so now that I know that there are some of these variables that are highly correlated, I probably do not want to include all of them in the model. If I choose to include kilocalories, which is what most people do, I probably will not include total fat or carbohydrates. Okay, and also sodium. So I will probably have to exclude. But let's say that you still want to take a look at the VIF values, and we can originate that by going to analyze. So you go and run your linear regression normally. So my dependent variable would be the body fat percentage. That's the one I want to predict with my independent variables. And let's say I'm including age, I'm including kilocalories, protein. I know that total fat was highly correlated with kilocalories, but I'm including this here so we can take a look at those VIF values. Let me just include everything that I have here for diet. Potassium, I have water, and I'm also including BMI. Okay, now if I click under statistics, here's the box that I get. Okay, you get the estimates for your regression coefficients, and when you look at all these other options, I'm going to click on collinearity diagnostics, and this is really the box that you need to click so you can get those VIF values. Okay, so I'm going to click OK here, and now I'm just going to scroll down to what interests to us, which is here our. So if you look at the coefficients, you have your unstandardized, your standardized coefficients, and then you have the collinearity statistics right here, the tolerance and the VIF that we talked about in the other video. If you recall, you need to pay attention to all the VIF values that are above 10 that represent a big problem, right? So you can see for kilocalories here, we have a 247 for that VIF. It's really high. And you can see that for all macronutrients, those values are all above 10, which means that these are highly correlated with each other. So I probably need to change my motto. So what I'll do now is to include kilocalories and protein only. Protein was moderately correlated with kilocalories. It was about 0.6. So I'm going to leave that in my model, but I'm going to eliminate total fat and carbohydrate. And let's see what those VIF values are going to look like. So I'm going to go back here, and I'm just going to go on my list, and I'm going to take fat from my model, and I'm going to take carb, because those are the ones that are highly related with fat. And so was sodium. I'm going to actually leave that so we can see what that VIF is going to look like. So now I'm going to run that model again, and here I am. Now you can see the VIF values are all below 10. Still, there is a concern. There is a sodium has a VIF of 5.8, and if you recall, if those numbers are above 2, you might also have a problem. So even with kilocalories and protein, I may have a problem here. So I'm gonna run my linear regression one more time just so we can see what happens when I eliminate protein and sodium from my model. And now if you look at those VIF values, you can see that they're all below 2. So which means that probably these variables are not really that related to each other, and they could be useful predictors in my model. Okay, so just to show you how you can derive these VIF values and the tolerance values with SPSS.